Think of your pipeline like hiring a candidate. If you only interview one person, you're gambling. But if you shortlist few strong candidates and compare them side by side and then choose, you make a far better decision. That's exactly what test and search does. Instead of trusting one proposal, you generate a small set, compare them, and pick the best one before the deeper valuation. Now, here is a trade off: more option equal to better quality, but also more cost and latency. I remember working on a more quantitative pipeline when I was trying to introduce a MapReduce style layer for forward curve generation. The tricky part was that the different seasonal patterns would favor completely different algorithms. One model performed better in stable period, while the other one with hyperparameters better handled the volatility. Initially, I relied on a single shot approach, but it was not getting us there where we wanted. So later, we let both algorithms run in parallel, and then using the judge and a feedback read angle, we actually shortlisted which one would probably perform the best, and then generate the full forward curve. If you are building a real AI system, this is where things will get really interesting. So one request: if you want to keep building system like this with me, make sure you hit the subscribe and press the notification icon. This course is designed you to take from basic to production grade thinking. I want you to always think this course is a one big example. We are not stacking random ideas. We're building pipeline where every piece keep running underneath. In previous lesson, we increased the challenge pressure, but kept the judge fixed. We are not replacing anything here. We are just extending the same mutation loop by adding the bounded search layer before the evaluation. So keep the system in your head: reader, proposal, judge, and feedback. Now we are upgrading proposal from one guess to best of few, and that's a shift. Here is the mental model I use. One failure comes in, we fan out into multiple candidates. We compare them, and then we pick the one survivor, then send only that forward. It's like a tournament. Instead of betting everything on one answer, you sample few. This is especially useful when outputs are unstable, prompts are ambiguous, or quality varies run to run. But yeah, you're paying for it. More tokens, more money, more latency. This is the underrated part. The read anchor doesn't ask, is this good? It asks which one is better. That's a completely different kind of intelligence. And it's usually cheaper if you need to run all the candidates in parallel before choosing it, then letting every candidate go through the full evaluation. This is engineering reality. There is no magic here. You're trading higher reliability for higher compute cost. You need to ask, is the improvement worth it? Let me explain with my previous example. When we actually had a forward curve, because of the forward curve's inefficiency, there was a material loss of trade. And that was a good enough reason for us to actually go for best of n cases. Not every use case will actually can afford best of n cases, but it's definitely, as I said, it's a case by case basis. If it is worth money, then it's a worth money. Let's zoom out again. Small fan out, cheap comparison, one survivor, controlled cost. That's how you keep this practical. Before we jump into lab, do we find the full implementation in GitHub repo, link below in description. Make sure you put it before we are about to walk through together. Like, let's get hands on. But before, get your repo ready and the chain loop implementation. The goal here isn't just to run it. The goal is to think like an operator. What you're gonna do, run the pipeline into one-shot mode, then enable best of n search and observe where the candidates are generated, where the re-ranking is happening, which one gets selected. What you look for? When you run those examples, look for, do multiple candidates differ meaningfully? Does the re-ranking pick what you expected? And does the final judge still behave the same way? This is the key. Judge does not change, only input and quality improves. That's boundary. That keeps this system stable. Now, once you've done that, we'll come back on the presentation. So let's go on hands-on. We are the hands-on now, and the best place to start is lesson 6 here. So, On that lesson 6, you already saw the diagram. And if you want to catch up, you can catch up on the previous lessons as well. Test time is a common algorithm. It's search and spend the compute on selection, not training. Now there are multiple ways of implementing test time. One is a full implementation. That means we get the final results and then compare. The other one is a partial result. In a mathematical sense, many machine learning algorithms can actually tell us what is a 25th optimization round look like, what is a sampling look like. So you can always run based on sampling, you can always run based on distribution, you can always run based on any other selection criteria that can reduce from full run to a partial run. But make sure the amount of partial run you do is meaningful. So whatever the re-ranker decide is a liking scenario. But if the partial run cannot be trusted, then there is unfortunately no other best way, but you have to make the full run and then make the choices. However, if partial can be supported, then it's the best use case. Most mathematical solutions can be precursored. That means we can actually identify the best candidate way before we complete the process. And that means we will only let the process move forward beyond a point where we have full confidence. Or you can choose in a waterfall manner, which means it start with the 10, then filter out 5, then filter out 3, and then remaining 2 runs to the end and 1 picked up. So there are many cases how you can implement test time search. There is no one particular answer. Isolation is a part of search contract, so please make sure the candidate run in a sandbox or a temp directory. They are not influencing each other or contaminating the result. The fix every make re-ranking meaningful. This is one other important pillar which I want to ensure, that every candidate is scored by a same judge. Do not make sure when the judge and the hints are provided are fair, they are not biased. Otherwise, generally it will produce a biased result. And that's one of the problem area where people very struggle to figure it out why the wrong results been selected. It's not because it's been intentional, but unintentionally some of the hints are biased. That means the re-ranker and the judge is always picking up and leaning towards the one sort of choices, whether they are right or wrong, because they don't ask the question right or wrong, they ask where is the better score. And that's why we need to make sure the score is as honest as possible. And search with drapes the deck token cost, which we already discussed. There is no one better answer or there is no one best answer. You have to pick up the right approach based on your use cases and also how much cost we can actually infer to get that kind of a business value. So there is a sufficient documentation here, and I would recommend this code anchors. So if you go on the best of n cases, you will find out what these algorithms look like and how we have created them, and there is enough documentations context to actually visit. In the examples and in the exercises, we actually ask to do some more work of it. So it might be interesting for you to evaluate and actually write your own re-ranker. In real world cases, there will be always multiple re-rankers. They are similar like a regular re-rankers, but they are deterministic here. You can also have non-deterministic re-rankers too. I have also seen for many top-end research organizations use the similar patterns as a harness agent to actually do for a reg retrieval. And this is a very powerful method. If you have very high value research going on and you want to find almost pin perfect context for LLMs, this is a very good model which can actually lead the mutation level, mutation-based content finding with proper re-ranking. It's one of the topmost pattern and implementation that you can go for highest accuracy at this point in where we are basically in terms of technical advancement. This is the highest possible quality setup that you can have for near perfect recalling and near perfect retrieval. So we already know how the status verify reset and event it works. I'm probably not gonna do, but if you want to re-rank, the very simple, you just use this function and command which will re-rank, and it will create two candidates, conservative and valid first. So not very difficult to understand, but however, let me honestly first put a disclosure. This example is not very depth. For actual re-ranker use cases, we need to have a very close to real world example, and to be honest, hardly 5 or 6% use cases in real world can actually justify the re-ranking process. So in this one, we are just demonstrating how it works, the pattern perspective. There is no real value out of it, out of the re-ranker. We haven't got that complex algorithm and that complex use case, because if you put even that complex use case, the challenge is for most of the learners, that example will become very difficult to handle. So here we can see here what happened. There is a value first approach, the candidate 2, and conservative first, the first approach. You can see that they have both used the different tokens, different values, and all sort of stuff. Finally, they sorted out everything, picked up. They basically fixed 54 rows, still need a mutation 65, and then the mutation patched it, and then the results remain inherent. So out of around 54 was actually fixed by the mutation primo itself, and that's what they fixed rows 54 played by the mutation itself. So that's basically an outcome we are talking about. Now go with the exercises, and you can see here most of them are medium or hard, but I would say these are one of the harder exercises to actually achieve. And dashboard is also running here, so we can go on dashboard and validate what the last run look like. The current artifacts, you won't see kind of a difference here, but yeah, it will be helpful to understand what each run and how it processes different things. Now re-ranking can also be extended into more advanced patterns, which we are not covering in this course, called hybrid fusion. Now fusion is there, 2 or 3 different candidate process the sections of code where we are not evaluating the atomic level of the candidate, but actually we validate the subatomic level, and that means individual group of records, which algorithm is dealing better, and then based on that we actually merge it. So we fuse it. We don't actually select 1 2 3, not out of that, but maybe 30 rows from 1, 60 rows from 2, and 30 rows from 3, and then we merge like a net merge and then produce a final result. It's also very powerful pattern, and that also can deliver us some advanced result, but that's not covered here. For delivering something like that, you need a very strong merge logic, and that's also a sort of a data structure challenge for anyone who would like to implement extension in this example, and put a PR. We'll be able to share with everyone if you manage to get that through as well. But yeah, that sounds good. And now I'm gonna go back without wasting a lot of time there. But here you can see the pretty much latest code 13/14. So we are good with it. Okay, we are back now. So now your loop can search, compare, and choose instead of blindly committing to the output. That's a huge step. But remember, this only works because it's so bounded. And in any self-improvement agent, the bounded is the keyword more than self-improvement, because self-improvement without bounded is most likely anarchy and randomized. But with the bounded, it can be a very meaningful purpose. So you control how many candidates, how much cost and latency, and that's engineering. Next, we are closing this course by adding the production safety rails and graduate the autonomy model. So your system doesn't just work, it behaves responsibly at the scale. And if you made this far, subscribe, stick with me, and let's finish this strong. Take care. I'll see you in another video.